it's going to be exciting. Hackers are adding telephone hacking into an arsenal of cybercrime. The upcoming talk is about the research in the field of mobile phone attacks. And we say hello again to Walter-Sprenger, CEO of Compass Security.
Thank you very much. And do you hear me? Now it's okay. I hope the battery is loaded well today, not like yesterday. I want to talk about mobile phone security and do a few demos. I hope I'm more lucky today, but it's Friday the 13th, so should be no problem. An extract from BSI status report said that cyber criminals are moving to mobile devices. They infiltrate corporations via mobile and wireless networks. So if you look at the market shares of mobile devices and application on devices, so you might think that Apple has a big market share. It was not like that. There are much other devices, like, for example, Symbian devices or Java supporting devices. But in the market of applications, Apple is leading quite a lot compared to the others. And I think this will increase in the futures. So how can you get a Trojan on a mobile phone? You have different connection, different interfaces. For example, email connection, applications you download. You have Bluetooth interfaces. You have GSM network. You download updates, for example. And you go to internet sites like you do with your laptop and browser. So mobile devices are critical and often forgotten. You don't often have a protecting company firewall on your mobile device. They are transported, left alone sometimes. You can lose them, they can be stolen. They communicate through foreign networks. For example, if you go to other countries, users often can do what they want on these devices. They can install applications at will. And as said, they can be stolen or landed for a half an hour, modified, brought back, and you won't realize anything. And this is critical. So, situations today in enterprises. Short sketch. So you're the IT guy, the administrator, or the IT security officer in the company. So I think there are not many companies that can prevent getting iPhones or smartphones. So let's see a little bit about mobile network, about positioning in the mobile networks. You have a mobile device, and this mobile device sends signals. And as soon as you send a signal, you can be located, theoretically. In a mobile network, we have several components. We have, for example, the mobile switching center, which is the gateway between the normal telephone network and the mobile network. Then we have a cells. Your device communicates with the cells, with the antenna. Then you have the base transceiver station. Base transceiver stations groups together several cells. And you have information register, for example, the home location register where your account is subscribed. And you have another register, the visitor location register. When you travel around, for example, in another country, then you are registered in the visitor location register. And in your country where you are subscribed, there is your home location register. So what happens if someone calls you on your mobile phone? The example, he calls from the public switch network. or from another GSM provider. So your call is routed through the MSC, Mobile Switching Center, to the BSC, and then out to the cell, to the antenna, where your mobile will receive the call. There are different names, technical names. LAC, this is the location area code, defines where your BSC is. And there is a cell ID. Each transponder has a cell ID, and your phone can recognize these cell IDs. Okay, if you want to see what location area code, what country code you are in, you can, for example, on iPhone, use this combination. Maybe can you show it on the screen? Okay, you go to the phone and you dial *3001. And then you press dial, and instead dialing a number, the field test mode is activated, and there you can see, for example, serving PLM, and here you see values. You see them in the following slides. For example, the mobile country code you see there, or the location area code. So what does this mean, this mobile country code? 2 stands, for example, for Europe, the first digit, then the other 2 for the country, like 228 for Switzerland or 262 for Germany. And then you have the mobile network code. This identifies your provider. So, for example, in Switzerland, 1 is Swisscom Mobile, 2 Sunrise, and 3 Orange. Okay, so you can read them out yourself, or an application on your phone can read this information. The cell ID, this is the smallest identifying portion, is your antenna ID, and now we have all the information. I've done this information, I read them out before. So for example, with a Swisscom contract, I have 228 for Switzerland, 01 for Swisscom, and 10,537 LAC, and the cell ID with 600,000 and more. So what can I do with this information? I can use a tool and take these values here and I get back coordinates, and the browser should start, and it says I'm there. The C is the correct one on the lake. But it tells me, here we are sitting here, but maybe I'm communicating with this antenna. So this is the location of the antenna, probably, and we are here. So this is also a database hosted by Google, where they registered all cell IDs, LAC, and so on, and you can send them this information, and they give you back the coordinates. So this is how they collect data. They have also GPS in their cars, or an iPhone can collect this information and combine it with the cell ID, and then you can build this database. So this was location with the mobile phone. There are other devices. I have one here. This is a GPS tracker. You can buy this on the internet for about $100 or $150, and it's nothing else like a mobile phone with GPS. So it has a SIM card inside and a GPS receiver. and I can communicate with this device. So what I use is, I have a cell phone here, and with this phone explorer I can send SMS. It's a convenient way to send SMS. So I send GPS tracker a command, begin. This message was sent, and if this device receives my message, it will answer with an acknowledge. Okay, and tells me begin was okay. Now I have to look up the other commands. In the next command, I define which phone number is able to remote control the GPS tracker. So I tell them only this device can send control messages and receive answers. And then I have a few possibilities with this device. For example, I can do a position tracking. So I tell the device, give me your position and do this 3 times with a delay of 1 minute. I can say do it forever with a delay of 5 minutes, or I can tell him send me only a notification if I move faster than 100 miles per hour, or give me a position if I'm away 200 meters from the last location. This is what I can do for positioning. I can also call with my phone to this device, and I can listen in what others are talking. So there is also a microphone in this small device, so I can listen into the room. So now, with the next few messages, we should get coordinates from this device here. So it takes here a little time. Yeah, we'll see. Maybe they arrive later. I proceed with the presentation. Okay, and that's detection location depends which database you used. I explained that already. There is also a possibility that your mobile phone is not connected to a cell at the moment. This means if you are not currently sending SMS or having a conversation, then your mobile phone must not be registered at a cell. So if you want to track someone, or if the police want to track someone at a specific time, they can send a silent SMS to the mobile device. And this means that the antenna will send out signals, and the mobile device will answer the signals. And then you have log entries within the telecom provider, and the police can afterwards go and ask them, give me the cell IDs at this and this time. So it's possible to locate users at a specific time together with the provider. This is described here. So first of all, if you're not registered, the signal is sent out to many different cells, and then your mobile phone answers, and then the network can locate your cell. So I want to send a silent SMS. Okay, and here we see I received this location information, but you see latitude and longitude and speed is empty. And that's because I don't have GPS, I cannot receive the signal inside here. So, but if you're outside driving around, then you have the coordinates in here. Okay, now first I send a short message to my mobile phone. It's this one. And I don't have to send a text. I just send an empty message. And now you can look at the phone. You won't see any reaction on the phone, but you see here on this screen that my handy or my mobile phone is receiving the message and answers with it. So I have communication with the phone, but the phone does not react. But we have, if you put the microphone near the phone, maybe you hear this do-do-do-do-do-do. You would hear that. Next topic, identification spoofing. Why should someone want to attack with a faked call ID? The call ID is the ID your phone sends with it that identifies yourself. But there are, for example, services where you have to identify yourself or which only accept incoming calls from specific number. You did it maybe a lot with remote access modems, where you said, yeah, only from a specific set of numbers you can do this remote administration. So there are providers that sell this service on the internet. It's called, for example, spoof card. You can buy a card and then you have an amount of money you can use to phone with a spoofed phone number. And there are other tools. For example, if you have SIP gateway, you can do this spoofing. So what I start here is a voice over IP client, SIP client, and I have defined a number, Germany 49, with many 6 behind. If I wanted this number, I would pay a lot for it, I think. But spoofing is much cheaper. So again, I make a connection to my mobile. And you see on the display, I see a fake number. I can even I should be able to talk here, maybe. Yeah. You could also talk, but I leave it here. Okay. You could also change this number or dial with your own number. What is, for example, an attack with call ID spoofing? You could use a man-in-the-middle attack. You make a call with a long number. You fake that number, and at the end, you put in the digits of a known number on the telephone. So, for example, I call Axel, and I put in the last digits from Ivan Büttler's phone. And because some phones only match the address book entries with the last digits, he will see the picture or the name of Ivan Büttler. And if he tries to call me back, he will dial my number and I will forward the connection to Ivan Büttler, and I'm so in the position to intercept this call and to listen to this conversation. You can do the same with SMS. With SMS, it's much easier to spoof. For example, you can use this for social engineering, or where you can, for example, control a service with SMS. There are a lot of services where you send start, stop, you buy logos and stuff, and you say, I want this, or you vote. And if you can spoof the sender number, you can fake these votings, for example. So other examples are where you can pay. More and more services will be available in the future paying with phones, or depends how it's implemented. It's not all implemented with SMS, but there are services that use SMS to pay for services, for goods, for parking lots, and so on. Or you could create phishing SMS, for example. Sometimes the telecom provider tells you you have phoned for that and that amount, and you can send a faked SMS where you tell him you have phoned for 1,000 euros. If you do not agree with this amount, please call this number, and then you put there a 0900 number. In Switzerland, these are very expensive numbers, and so you can make money because they probably will call you back and complain, and then they will end up on a voice recorder or so on. Or another thing is you get, for example, flight information. You can leave your competitor at home, send him an SMS that his flight is leaving later, that he will not appear on the airport. I've prepared 2 demos here. First, an SMS phishing. Okay, I have here a script where I can send SMS. I send it again to this device, and the sender ID in this case is, for example, Bank XY, and the message is this: we are proud to announce our new mobile portal login to HTTP and so on to activate portal team. So let's send this spoofed SMS. Hope that it arrives. Yeah, we have a new message from Bank XY with the text I sent, and there is a link. In smartphones you can directly click on this link. Okay, here you want to connect to the access point, you can cancel. And then you have to make it bigger. Now we see his iPhone expert, Axel. Okay, and here is a normal phishing site requesting username and password to activate the portal. You can enter something. Do you know how? Your username? Okay, so he entered his username and password. They have been sent to my web page. I display the log file here of the web server, and they are a little bit encrypted, decrypted, and he entered Excel 1133, correct?
Okay.
Okay.
That's correct.
Okay. So phishing with spoofed SMS. And because of the spoofing, it's like in email, you can say it's your bank or your company or your friend that is sending you an SMS. You can use text as spoofed sender or also numbers. And then another demonstration. Yes, we're ready. Again, number. And now I take a mobile provider as sender ID. And the message, congratulations, you won an iPhone. To find the next location to receive your iPhone, click on the link and press OK. Okay, new message from Swisscom. I trust these messages because they send me a lot of messages about how much I spent and so on. So now, thank you very much. And I'm automatically redirected to the Swisscom homepage. But what happened in the background? I have to find the URL. Oh, here. I have the received coordinates. Can click on them. And I have an exact location of this mobile device. This time the location used is a geolocation API from the Safari browser together with the Wi-Fi access point that are detected in this room or in this location. I showed the presentation with normal browsers yesterday. This is combined SMS, spoofing, social engineering, and using geolocation. Okay. Another type of attack is SIM application toolkit. SIM, this is the card you insert in your mobile phone, and your mobile phone has an interface that communicates to this card. It's like a crypto chip. You have 6 pins, and there is a communication between these two. This SIM card is used to identify yourself in the network, could be used to load applications on it, for example, to load certificates on it, or applications that are on your phone. Maybe if you have a Vodafone, you have maybe Vodafone applications. They are loaded or configured from the SIM card. These are what I said. So whenever you make calls, the SIM card is contacted and there is a communication between your phone and your SIM card. What you can do is insert a little piece of plastic here, and this little piece of plastic has 2 sides. You put it between the SIM card and your mobile phone. And there is a little chip on it. You can program this chip and tell the phone what you want to do it. So below you see this is the development kit. There you can insert the SIM card and insert it in a phone. Then you can connect it to your PC and write down your own application. So what you can do with this, for example, again, a man-in-the-middle attack, you can say whenever he dials a number, then first dial my number and depends the number he wanted to dial. So you can forward this call, so you can intercept call, or you can say every SMS that is received or sent by this mobile phone should be forwarded to someone else. This was a hardware-based attack, and I think you know malware on mobile phones, for example. A very famous one is the FlexiSpy. You can buy it. Here, FlexiSpy for about $300, and it allows also a remote control of your mobile phone. You can, for example, install it, and afterwards you say hide the icon and also remove a jailbreak. If you use jailbreak to install it, for example, on iPhone, and then the application won't be visible in your phone. You can configure what it shall intercept. Shall it intercept calls, SMS? Shall it receive GPS information? And how often shall this information be transmitted to a web server? Here is such a web interface of FlexiSpy. I want to show this live here. Log into the web interface. Okay, and here I see all events. I, for example, can see which voice connections were made. So we see my mobile phone called it this morning, or he had German calls. You see at which time. Then you can see, for example, SMS that he sent or received. You can click on them and read the text of the SMS. See if there's another one. That he has a ComBox message, so on. If he has email activated on the phone, you would find emails here. You could check the locations. Let's say, is this today? 1641. Let's see how the phone is. Where is this? In Zurich. Okay. The phone is with Marco Di Filippo. He's traveling from Zurich to here. Will be here this evening. So what I try, if I can call this device, this is an iPhone where the FlexiSpy is on it, because it's configured that when I call it with my phone, it will take the call, do not display anything on the screen, but activate the microphone. So let's try if we can hear something. What is he doing? Well, you see, we hear. He does not realize that we are listening to him. So, a lot of possibilities. With a newer version of FlexiSpy, you can also listen to active calls. Or you can do GPS tracking also with this functionality. And try to find out where he was. So we have locations in Switzerland, Munich he was, and in Bonn the last few days. With this, it's not always switched on because he doesn't want that we listen to his conversations. So he only switches on when we have a presentation. Good. How does it work? Collects the information, sends it to a web server which you can access and query. So I don't have questions for you, but maybe you have questions for me. Please.
It happened to see on the TXT that you had also mentioned to SS7. Am I wrong? My eyes mistaken, or I was too much accurate? Do you have anything to tell us about SS7?
The connection, also the communication protocol in the network is SS7. And for example, if we have an interface to send spoofed SMS, it's an SS7 interface. And we have also demonstrations about home location register lookups, and you do this with SS7 interface. So, but unfortunately, the credits have gone out this morning because the demonstration was shown in BSC Congress in Germany, and they had a lot of users trying this out. So today we have no credits left, therefore I could not show the demonstration. I'm sorry.
Do you use route messaging?
Route messaging, yeah.
Okay, because if you use that, it's not good for US, for example.
For your?
For US. It's not good for US route messaging.
Ah, it's possible.
Try to query to mobile in US, it
Doesn't work?
work good.
Okay.
But I got a couple more guys if you want.
Yeah. Okay. Thank you. Other questions?
How do we bring the program on the phone? You have to grab the phone and put it on, or can you do it remotely? Can you do it without the guys knowing that you do it?
For example, this FlexiSpy. Currently, I only know that you can bring it on if you have physical access to device. Also, FlexiSpy, you need to jailbreak an iPhone, for example. Yeah, and but maybe if you find a vulnerability, let's say in MMS, we have heard something on Windows mobile phone, or if you have a vulnerability in Safari, for example, I think one time it was possible to go to a website and you could do the jailbreak on this website. So if you have such scenarios, then maybe you can also distribute the application with such a vulnerability. But I haven't seen it in a live demonstration right until now.
Another question, do you know, is there any documentation what hidden SMS and MMS functionalities out there?
I haven't found documentation. I wanted to research this topic because it interests me very much. I found documentation about the protocol you use to send the SMS and what bytes mean what. And there are also tools to send special SMS, but I didn't find out if there is a documentation of unwanted functionality. I can imagine that there may be unwanted functionality, but that can differ from phone to phone. Maybe Nokia has something built into his devices to query for cell ID and LAC, but I don't know. I didn't find out yet.
Thanks a lot.
Another question here?
A few years ago, I see a similar demonstration on the FlexiSpy, but on the Nokia 3G phone. So is it the mechanism behind it, is it the same, or is it a completely development for iPhone?
Oh, the FlexiSpy, you can have it for Nokia phones, for Android phones, for iPhones, I think also for BlackBerry. they create it for different phone types.
No more questions? So, thank you very much, Walter-Sprenger.
Thank you for your attention.